Matrix multiplication is a very simple theory. Everyone knows it. But the problem is that most of them do not know what is the real intuition behind it. So that's what my goal in this video. And I'm going to illustrate how matrix multiplication is implemented. And I'm not planning to go deep into how it is being done, the inner mechanisms, but the main goal is going to be how to calculate a matrix multiplication and what is the intuition behind it. So suppose there is a classroom and there are three students, student 1, student 2 and student 3, and they are taking three subjects A, B and C. And for the first student, so we create this table. First student has taken 75 marks for the subject A, and we can see third student has taken say 30 marks for the subject B. So this is a sort of a data sheet, or you can think of this as an Excel sheet. And we want to calculate a grade or a score, overall score for each student. We want to give each student an overall mark, overall score. So how are we going to do that? So there are many ways, but suppose our strategy is going to be taking a weighted average of these scores. So suppose subject A is going to be very important and subject B is not that important, but it is also important but not that important. So we must weight this subject A more when compared to this subject B and C. And for that we define weights. So these are the weights. 0.5 is the weight for subject A. 0.5 is the weight for subject A. 0.2 is the weight for subject B. 0.3 is the weight for subject C. And as you can see, 0.5. So A gets a much bigger weight, much larger weight. As a result, this subject A is going to influence the score more. So how are we going to calculate the overall score of a student? So it's very simple. Suppose we will take the first student as an example. So what is the score? So we multiply 75 by 0.5, 52 by 0.2, 81 by 0.3. Now we have weighted them, but we want one number, so we add them up. And so we have taken, essentially we have taken a weighted average. And what does this give us? 72.2. 72.2 is our new first student's overall score. And similarly we can calculate scores for all the students. But before moving into that, I would love to show you something very interesting. So similar to previous step, there's another way we can think of calculating this weighted average. So simply take this row for student 1 and place it on top of this column. So 75 on top of 0.5, 52 on top of 0.2, 81 on top of 0.3, and we multiply 75 by 0.5, 52 by 0.2, 81 by 0.3 and add them up. So we get the score 72.2. Once we do this for all the students, we get a score column of scores. 72.2 is the score for student 1. 43.8 is the score for student 2, so on and so forth. And that's great. So these are the scores we give to these students depending on our, so this is based on our weight mechanism. And so these weights are quite arbitrary. I decided these values. But suppose we want to calculate, rather than this is a weighted average, but suppose we want to, our scores should be the sum of these scores and sum of the scores of subject A, B and C. And what is the weight? What are the weights we need to have? So these weights, what are the weights we are going to have? 1. All the weights are going to be 1. So simply think like 75 is multiplied by 1, 52 is multiplied by 1, 81 is multiplied by 1, and all of them are added up to get that which gives us the addition of this row, and that is going to be the simple, that is going to be the sum of the scores of for the subjects, and that gives us this new column of scores. So like these weights are quite arbitrary, and a very interesting experiment or a homework would be try to find out what is the best, what is the, not the best, but there's only one way to calculate this, but what are the weights we should put here in order to calculate the average of these scores. So previously we calculated the weighted average, but now we want to calculate the normal average. So essentially each and every subject is going to get the same weight, equal weights. What are the weights we need to have? So for example, the average new score we want to calculate for student 1 is 75 as 52 plus 81 divided by 3. So what is the weight we should put here to calculate this? And that's great. And again we will move into the previous example. So now we should think about computers. So computers, suppose these are labels: student 1, student 2, student 3, A, B, C, or identifiers or keys, and these are values. So inside the computer, rather than storing this table, just like simply taking this table and storing it in the same way, we will store these numbers in a separate place, and suppose like think these labels or identifiers are placed in another place. So these numbers are, we pick them, pluck them out, and we store them separately, and this creates a matrix. This is a matrix, and actually this is going to be a 3 by 3 matrix, and this is also a matrix, and this is a column matrix, and in this particular example I will call this a vector of weights, and the result is also a column matrix or a column vector. And in the matrix notation we will write it like this. So this is the score matrix, 3 by 3, 3 rows and 3 columns, and this is the weight vector or the weight matrix, and it has only one column, and by multiplying it we get a score. So grade, rather than telling like rather than naming it as scores, like we will name this as the grade vector, like that. So and so that is the idea of matrix multiplication, and so that's great. So I mentioned that the weight vector we discussed here is quite arbitrary. So I have replaced the weights with like generalized versions. So W1, W2, W3. So this is a generalized weight vector, and so this makes the problem much more flexible. And so this way of looking at this problem is really interesting and really beautiful. But there's another way, and it's going to be quite important, especially when it comes to machine learning. Before moving into that, for any student, the score is going to be, the grade we are going to give them would be, take the score of subject A, multiply it by W1, and take the score of subject B, multiply it by W2, and take the score of subject C, multiply it by W3, and sum all of them up, And so this is going to be the new version of the same problem. So simply what we are telling is, take subject A, multiply it by the weight W1, take subject B, multiply it by the weight W2, take subject C, multiply it by W3, and add them up, which gives us this overall grade. So what we have created here is a simple neuron, simple artificial neuron. And so, and we call this a perceptron. But there is another small technical detail, and it is that so actually from a neuron we are not expecting it to simply calculate a grade or a simple score. We want it to perform sort of a like a decision. It should take a decision. And how is it being done? So we introduced a concept called a nonlinearity. So suppose in this case we want the students to have a pass grade if they are above 50, overall score is 50, and a fail grade if they get an overall score below 50. Above 50 is pass, below 50 is fail. And so for that we introduce a non-linearity like this. So 50, above 50 we get 1 means pass, and below 50 if the value here is below 50 we say 0. So this is a non-linearity. And once this is done, so now we have created a decision machine. And so now we have a full artificial neuron, and in a more like in general neural network what we do is what we connect, we feed this decision of this neuron to another neuron. So decisions are being fed into deeper layers to take better decisions, more complicated decisions. So that's what we do step by step. We refine our decisions. We come like we now the whole neural network can take much complex and versatile decisions. So that's the beauty behind these neural networks and matrices. So before ending this video, I will show you this. So this is the way we define. So we can call this matrix. This is the same matrix we saw before, but we call this matrix the data matrix. This is the data matrix. Actually, this is how it is being stored inside the computer. And these are the weights, and weights are being learned. These are not fixed. These are being learned. Before, like in most of our cases we discussed earlier, we kept these weights fixed, but it is not going to be easy. We want them to be learnable. So like these weights need to be like knobs or switches, that's so that we can slowly change them depending on the context and depending on our target. So that's it. Now hope you have a very clear idea of what matrix multiplication is, and hope this would help you to have a more holistic idea on what matrix multiplication and what is going on behind neural networks.